Okay, I'm going to demonstrate for you the Hanby Environmental Colorimetric Field Test Kits for chlorides. The same kit is used for both testing water for chlorides as well as soil for chlorides. So I've already pulled out the things from the kit that I need to use, but the kit has the reagents to perform 30 chloride tests, whether they're soil or water, in that kit. So with that, the instructions here will be in a laminated book for you. I just, before I laminate the book and put it in the kit, I wanted to record this video so that as part of the instructions, I can include the link to this video, this instructional video on how to utilize the kit to perform the water or soil analysis for chlorides. So with that, again, I've already pulled the things out of the kit. As you see here, we've got the test tube that the analysis will be performed in. I've got my beakers out, and I've got my color development solution right here. In the kit, it looks like this: color development solution, CDS, color development solution. There's a 100 ml bottle here, and because it's chemicals, I've got it taped up for shipping purposes, and there's 3 of those in the kit because each test could take up to, say, 10 mils to perform. So we've got 3 bottles, 100 mils a piece, which is 300 milliliters there. We've got 2 water bottles because water is utilized as part of the extract of the chlorides from your soil sample. And then we got the 30 test tubes over there for the 30 different analysis. We've got syringes from the kits. The blue ones are for sample extraction, and the white ones are CDS for the color development solution extraction. Also, as you can see, I've got my safety gloves on. There's also safety glasses included in the kit, so you want to make sure that you're protecting your skin and your eyes while you're doing your analysis, so making sure that you put on your safety gloves, which are included in the kit, and your safety glasses prior to getting started. With that, let's go ahead and get started with doing a soil analysis. And I'm going to go ahead and, while we're doing it, I'm going to change to the instructions in the kit here so that it's got pictures and descriptions of how to do it. The second page here shows the inventory parts that are in the kit, but then we go to the step-by-step instructions here that are included with kit with pictures and descriptions. And then, of course, behind the pictures and descriptions is a full detail of the steps in the process, so that you can read through that and be familiarized with it. But just while we're doing the analysis, I figured I would have the pictures and descriptions shown so we can see it. So it says to get out your scale, which we've done right here. We've got our scale out. We've got our spatula or spoon out. We've got our beakers out. And we have our sample. So our sample is here, our soil sample. So it says what we need to do is go ahead and get our scale ready to use. And we want to put an empty beaker on the scale and turn that on. And it's going to tear the weight of the glass out to 0. And we want to measure out 5 grams of soil from our sample. So here's our sample. So let's go ahead and measure out 5 grams of soil. We've got a sample here. It's a little bit wet, but this is our sample. So we are currently at 3.5. So we'll add a little bit more to our sample here. And that's at 5.14. So we're slightly over. I might just grab just a tad just for fun, but it's not necessary. 5.14 is fine. And in fact, that caused me to get too much. So 5.02 right there. Okay, so we're going to go with that. 5.02 is our sample size. So we've done measuring out our soil sample. So we can take that off and get our scale out of the way. And now we've got our sample that has our chlorides in it. So the next step in the process is to use another beaker right here and measure out 25 milliliters from the water bottle that's provided. So we're going to get our 50 ml Griffin beaker, and we're going to measure out 25, which is halfway between the 20 and the 30. I'm a little bit over, and that's fine too, but just for grins. So here we are. We got our 25 milliliters of water here from our water bottle. And we're going to add that into our sample. Okay, now that we've done that, we want to use the other end of our spatula to stir that water around in our soil sample. Okay. If there's chlorides in that soil sample, the water is extracting them from the soil and pulling it into the water. Now, at this point, I've been showing you how to use a soil sample, or how to analyze a soil sample. At this point, from this point forward, it's the same whether you're doing a soil sample or a water sample, because we've now created a water sample out of our soil sample by utilizing the water to extract the chlorides. So now the steps in the process to do this, continue with the soil analysis, is the same as if it was a water analysis, because effectively we've created this water sample. You just wouldn't have to weigh out the soil and add the water to the soil. If it was a water analysis that you were performing, you would just, go to the next step, which is this, grabbing, we've gone through step 3 there. So step 1 was measure out the 5 grams of soil. Step 2 was put in the 25 milliliters from the water bottle. Step 3 was to stir the soil mixture. And now we're at step 4, which is use the blue syringe marked with sample, the blue syringe, and draw up 2 or 3 mils from this soil water mixture. Or if you were just doing a water analysis, this would just be your water sample. So you use the blue syringe. So the best way to do that is when you put the syringe tip in, is to keep it beneath the water surface and push it a couple of times to get any air bubbles out, and then syringe up 2 or 3 mils, because this is a 3 mil syringe. And then in this case, I've got it syringed up to about let's see here, about 1.5. So what we want to do at this point is we want to make sure that we've got the amount syringed up to an accurate measurement point. So I'm going to push some back to where I can get right at the 1.5 mil mark in my syringe, because effectively we are going to use this syringed amount. We're going to use 1 mil exactly. So I want to, after I syringe up, I want to push some out so that I'm at an accurate graduation, so that I can pay attention to putting only 1 mil in. Now that I'm at 1.5, so I will syringe from 1.5 down to 1/2 in order to put in my 1 mil, of course. Now I'm going to grab my test tube, and while I'm doing that, let's change the instructions page to show that. So at this point, we've got it down to where we've got the 2 to 3 mils drawn out of the beaker, and then we pushed it back so that we got it to the 1 mil mark. So now we're going to go to the next page of instructions, which tells us we're going to release 1 milliliter into the test tube. Okay, so that's why I said to syringe, push some back. And we have the test tube, and as you can see, it's preloaded with this color indicator. It's yellow down at the bottom. There's a drop of color indicator in there already, and that's why we have it taped up. So prior to use, you're going to have to remove the tape so you can open the top, and that way you're able to add the 1 mil that syringed from the sample into the test tube. So we tape this on there because that color indicator is already preloaded in the test tube for you, and we want to make sure for shipping purposes and that type of thing, when you when you're shipping things and vibrating and bouncing around, that type of thing, that we don't have an issue. So I'm going to use these scissors real fast to help me, because it's get this tape off here. Okay. All right, so now we got the tape off, and we can now open our test tube, and we are going to take that blue syringed amount from our sample. And again, as you can see, my graduation is at the 1.5 1.5 mil mark. So I'm going to push it down to this 1/2 mil mark right there so that I get 1 mil of the sample extract into this test tube. And there we go. Now, as you can see, that color indicator, which was yellow, has changed to a yellow, our water, if you will, which was slightly tinted because of the soil extraction. But as you can see, it's got a yellow tint to it now, okay? All right. Now then, we're going to get our white syringe labeled with CDS, which stands for Color Development Solution, and one of our Color Development Solution bottles, which I showed here, CDS, and untape it, because it's also taped up for shipping to make sure that, you know, vibrations and stuff in shipping don't cause a problem. So in this case, I'm going to use this bottle, and we're going to open the bottle up, and we're going to use this white syringe, which is a 5 mil syringe, and we are going to do the same thing. Push out the air with the tip below the surface, and then syringe up to the past, actually, the maximum. In this case, I didn't quite get there. Let's get some more. We want to go past the maximum 5 mil mark right there, and then push it back to the 5 mil mark again so that we have an accurate measurement. Okay, so now we've got the syringe fully loaded with 5 mils. Okay, and it's important to have it syringed back to the accurate graduation, because from here, the amount of this CDS color development solution that we use correlates to the concentration level. So we want to keep track of that, okay? So here we go, and a good rule of thumb is to release this CDS solution into the test tube in amounts of like 1/2 milliliter at a time until you start to see color develop of orangish or reddish color at the top of our sample solution, at which time you want to do it in drops, and we'll get to that point. But at this point, I want you to observe the sample solution at the bottom of the test tube and see how it's yellow right now. So as we start to slowly release some of this color development solution in there, as you can see immediately, as soon as it hit it, there was a little bit of a red tint that took place. And as more gets added, you see that it's going to start changing to a milky, you see that every time the drop hits it, it's turning a little bit of red, and it's turning a little milky white there at the top right there. But that red that we're seeing, when you start seeing red, oftentimes you'll just see milky white right off the top. When you start seeing red like that, it's time to actually cap and shake our test tube. Okay, so let's do that. Cap and shake our test tube. And immediately we are seeing this red solution take place. It's changed from yellow to red, which means that it's dropping out the chlorides. And as you can see also at the bottom, we're starting to see some accumulation of a precipitate. It's discolored. You notice it's red right now. Typically, in a higher concentrated chloride sample, that discoloration precipitant would be the chlorides. It's the chlorides that are dropping out, and typically it would be white. When it's white, then that means the reaction isn't complete, and you need to keep on adding this solution to it because there's still chloride left in the solution, because the chloride is still white. It's when it drops out and it discolors like this, means the reaction is complete, and that's when it's time to look back to see how much of the solution we've used to correlate back to concentration level. But at this point in time, we still have a yellow tinted solution here, which means there's chloride still in the solution, so we need to add more of our CDS, our color development solution. So we want to add some more to it. And as you can see, again, that solution is turning red. So again, it's time to cap and shake our sample. And let it sit for a second. And we would see the solution on top as the chlorides drop out or precipitate out of solution and they're discolored as they start to settle down there. Then that is telling us that, and the solution on top will clear up. It'll tell us that the reaction is complete. And that's the time at which we need to pay attention to how much of the color development solution we have used, as well as how much precipitate has accumulated at the bottom of the test tube. So in this particular case, because we got that bright red, we very, very quickly, as opposed to still having yellow sample solution, as well as that white or very light colored chloride precipitant dropping out of the bottom, means we have a sample that is very low in concentration. Typically, high concentration, kind of like this picture shows over here, you're going to see a lot of accumulation of discolored chloride at the bottom, the sediment of the precipitant, which is, it's actually the chloride, but it's discolored. So you'll see a light color, and it will be a bunch when you have a starting concentration as high. But as you can see in our sample here, we don't have much at all accumulated at the bottom, and our sample is still pretty clear. So other than the red color. So as you can see in the calibration here, on the high concentration on the right at 25,000, you can see it took 7 milliliters of color development solution to get there. And when it got there, it finally cleared up the solution, and look how much of the precipitant, which is the discolored chlorides, that have dropped out of solution at the bottom down there. And then as you move to the left, which is half the concentration at 12,500, you've only got half the amount of solution in there. From 7 milliliters, you drop to 3.5 milliliters. And you've only got about half of the amount of the discolored accumulated chloride precipitant at the bottom. Likewise, moving over to the center calibration, which is 5,000, you've only used 1.4, so the solution again is less in the test tube. And look how much darker the precipitant. It's less precipitant, which is the, again, accumulated discolored chloride at the bottom down here. And so not only is it so much less, it's also starting to get darker. And then for the calibration right before the blank, the 2500 calibration, it's again less solution in the test tube. And look, it's got that dark and less accumulated precipitant chloride at the discolored chloride at the bottom down there. So in other words, in order to calculate concentration, we're paying attention to how much solution is required to drop the discolored precipitant, which is the discolored chloride, out of solution to the bottom of the test tube and accumulate. And in higher concentrations, you're going to see a bunch down there, and it took a bunch of solvent to do it. And then as you move to lower concentrations, it's taking less solvent. As you can see the stair step here, from there to there, from 7 mils to 3.5 mils to 1.5 mils to 0.7 mils. So less solution being used of the color development solution is lower concentrations, and also at lower concentrations you're seeing less of the accumulated discolored chloride at the bottom, as well as it gets darker. So it's much lighter over here, and as you go to lower concentrations, you get much darker. And over here, as you can see in our blank, you can see this is just 2 drops of the color development solution put into the solution, and there's no accumulated powder down there, and it's really a bright red color, very similar to what we saw here. So we had a sample that it has hardly any chloride in it whatsoever, because as you can see, there's hardly any powder that is accumulated here down at the bottom, which is the discolored chloride. And we hardly have any solution that we added. In fact, what we're going to do is take a look here at our syringe, and effectively we have only put in a 1/2 ml of our color development solution. So only having used a 1/2 ml, we can now back into, and it all makes perfect sense. We've only used a 1/2 ml, which is why there's hardly any solution in here, and there's only a little bit of accumulated discolored chloride at the bottom, because so here it is at 2500, which took 0.7 mils to get it, and we've only put a 1/2 ml in there, and as you can see, we have a darker color than that. And I'm going to bring that over to show. I'll let you grab this copy here, and I'll flip to that calibration there. So here we only used a 1/2 ml, and at 0.7 mils, this sample had a lot of accumulated discolored chloride there because it was 2500 ppm chlorides. In this case, we only used a 1/2 ml, so we have less powder or discolored chloride at the bottom down here. We have, and so we know we're dealing in low concentration. So, and if I can see how much darker the discolored chloride is in the test tube. So darker discolored precipitant powder or discolored chloride, darker is low concentration. Low concentration is also indicated by not only the darker color, but the amount of it, which is very, very small in our case, as well as the amount of color development solution that was used in the process. So are we over here? No, because that's much lighter in color. It has a whole lot more solution that was used, and there's a whole lot more powder. But as we come over here, and we know that we only put in 1/2 ml, because we syringed up 5 mils and we're at 4.5 mils left, so we only used a 1/2 ml of our color development solution, and so that means we have a very low concentrated sample over here that falls between 0 or blank, which only required 2 drops, and 0.7, which is 2500, and so we used 0.5, and so we know that this sample is probably somewhere in the tune of 1,000, 1,500, maybe 1,700, but what we do know is it's below the 2,500, which required 0.7 mils and had a lot more accumulated discolored powder. In this case, we have a little bit, and it's much darker. So I would say this is probably somewhere between 1,500 and 1,700 ppm chlorides in that soil sample. And the threshold of interest when you're dealing in chlorides is 3,000 ppm, which 3,000 falls between these two calibrations, and we are nowhere near there. We have a lot less color development solution that we used. We have a lot less discolored chloride powder at the bottom of our test tube, and it's much darker than those. So in that case, that's why I say it's lower than 2,500, because we didn't use 0.7 mils, we used a 1/2 mil. And then, of course, how much, since 1/2 mil is pretty close to 0.5, is close to 0.7, so that means we're dropping off from the 2,500, but not quite half. Half would be 0.35 mils, and we used more than that. So, you know, it's not half of 2,500, which is 1,250. It would be closer to 1,500 or 1,700 is what this sample is. So, but since the threshold of interest is 3,000, we know that we are below the 3,000 threshold, so this sample is fine. And included in the instructions, I've also included a little chart here that kind of talks about that, where in the chart it shows mils versus concentration, so you can easily correlate back to how many mils you use to do to change the color from the yellow tinted color to the red color, the reddish brownish color, whatever it is. And you can back into the concentration level from there, because there's a direct correlation between the amount of color development solution used and concentration. And that is validated also by looking at the amount that you released into the test tube from your syringe, as well as visibly seeing it in your test tube, as well as visibly seeing the amount of accumulated discolored chloride at the bottom of the test tube as well. And that is all shown here in the calibration. So again, over here in the upper calibration at 25,000, you've got a lot more solution that was required. You've got a lot of discolored chloride at the bottom, and it's much lighter in color. That was actually 7 mils at 25,000. And then half of that moving to the left, you got a little bit darker discolored chloride here, but it only took 3.5 mils to get there. So half as much, which means half as concentration, from 25,000 to 12,500. And then over here, the center calibration, which is the 5,000, is 1/5. Look how much darker in color, a lot less accumulated discolored chloride, and a lot less solution used. And then to the left of that is the 0.7, much darker, a lot less solution, a lot less powder, and 0.7, which represents 2,500. And the reason why these are the most important is because obviously the threshold of interest is 3,000, which is right in between these two. And so the rule of thumb is, if you had to use 1 milliliter or more of solution, color development solution, 1 milliliter or more is going to put you over the threshold of the 3,000 ppm. So just know that as a rule of thumb. If you use 1 mil or more of the color development solution, you are over the threshold of 3,000, and so you need to continue to remediate. So with that, that is a summary of how to utilize our new Hanby field test kit for chlorides. And yeah, thanks for tuning in and your interest level.